Hi folks, we're about to revisit Frieze Pattern, which I've been on this channel before and linked to a Numberphile that I'll link in the doobly-doo, because I've completed a thing which we'll get to at the end of the series, which I couldn't find anywhere else online, which either means I'm rubbish at Googling or I'm the first person to put it all together in one place. So, for the uninitiated, those who haven't seen where this starts, here is a field of ones and here is a field of natural numbers, which do have a reason to get behind. They're not arbitrary, and we'll see why they need to be constrained in some way. I happen to have chosen a set of 8 today that look like this, and these repeat. So 1, 4, 1, 2, 3, 2, 1, 4, round again, 1, 4, 1, and so on. And similarly, working backwards, 4, 1, 2, 3, 2, 1, 4, 1, round again to 4, and so on. So there's a generative rule to completing this set. If we take any pair of these and multiply them, so 2 3s are 6, and subtract 1, we will always find that's a multiple of the row above. Now with this being 1, that's not a very interesting claim, so I can do those calculations quite quickly to fill that in. So 4 1s are 4, subtract 1 is 3, so 3 divided by 1 is 3. 4 1s are 4, subtract 1 is 3, divided by 1 is 3. 4 1s are 4, subtract 1, divide by 1 is 3. 2 1s are 2, subtract 1, divide by 1 is 1. 3 2s are 6, subtract 1 is 5, divide by 1, 5. And if we continue, we will get a collection of 3s, and so on. And this repeats again with an 8-digit repeating pattern, in this case 1, 2, 3, 4, 5, 6, 7, 8. So that's the pattern that repeats. Now, round we go again. 3 3s are 1, take 1 is 8, divide by 1 is 8. And this is the first one that starts to seem slightly strange. 3 3s are 9, take 1 is 8, divide by 4 is 2, and we get a natural number again. We're dividing by 4 and it happens to work. Well, I say happens to, this is well proven. 3 1s are 3, take 1 is 2, divide by 1 is 2. 1 5 is 5, take away 1 is 4, which is a multiple of 2. 2 2s are 4. 5 5s are 25, take 1 is 24, which, oh look, that divides by 3. And it turns out this pattern is this again. 1 2 3 4 5 6 7 8. That's the span that repeats. So that'll be another 2 there. 4 3s, and that'll be a 1, I think. 6 7 8, yeah, 1 there. You can build this out. Alright. 2 8s are 16, take 1 is 15, which does in fact divide by 3 to get 5. 8 2s are 16, take 1, 5. 2 2s are 4, take 1 is 3, it divides by 3, which is 1. And if these were random numbers at the start, it's very unlikely we continue to have integers as we work our way down, which I think is interesting in itself. Maybe not worth a whole video series, but it would be a thing that I would certainly have noted had it come up anywhere else. And some of you might already be noticing an interesting thing, and there's something going on here, but we will save it for a bit. So 5 5 is 25, take 1, divide by 8 is 3. 2 1 4 1 4 1 2 3 2. 1 in there, 2 in there. And 2 3s are 6, take away 1 is 5, divide by 5 is 1. 2 1s are 2, take away 1, divide by 1 is 1. 1 4 is 1, take away 1, divide by 3 is 1. And these are all 1s, which means whatever we were doing has come to an end. And of course, because this is pre-planned, you can see that's all the rows I prepared, so I knew that was happening. So this is a Frieze pattern. A Frieze pattern is anything that repeats with translational horizontal symmetry. So these 8 digits repeating in a cycle means the next 8 will be the same, as will the next 8 and the 8 before. So this is an infinite array. And one thing you can do, the thing I've done before with them, is to assign each number a colour to make it vaguely interesting. And the unanswered question for this video, which has been answered elsewhere, and I'll cover in the next video, is how this list of numbers came to be, and what lists of numbers are acceptable and what aren't, and where they come from. It's a rather remarkable thing. So let's get started and do some colour. I'm going to do all the ones in red. We'll see how my editing goes to make this complete. Alright, so that is a Frieze pattern. So that's a Frieze pattern generated from this 8 numbers, and the rule of a product to take 1 divided by that gets you that. And you can see patterns arise. And the open question, which I'll be covering next video, is how come those numbers work, as it seems fairly arbitrary where these came from. Until next time.